our next presentation, which will be given by Fabrizio Diri on behalf of Ernesto Palomba. We have MOVIDA, an instrument for the characterization of lunar dust charging and levitation process and measurement of volatiles.
So I show you the concept and what the developing of MOVIDA instruments for the characterization of lunar dust charging and levitation process and measurement of volatiles. The surface of the moon is continually exposed to the solar wind, UV radiation, and this causing photo emissions. And so it could be developed a surface charge and electrical field close to surface that made the particles injected to the plasma, and these particles are going to be levitated in the surface. So it is possible that this particle is deposited on different parts of the lunar surface and also on the different, for example, sensitive equipment. So this could create some problems for the crew, for example, or to the equipment that are going to be used. In particular, the lunar regolith is a broadside, has a broadside distributions, and it was continuously created.
Fabrizio,
yeah.
We just see that your first slide, and we
sorry.
Yeah.
Can you check the second one?
Okay, yeah, now we can see the second one.
Okay.
If you want to put it onto the full screen mode, you can look down at the bottom right of the screen.
If you can see that slide, they can maintain it.
Yeah, okay. Yeah, all right.
Okay. I was to the third slide, and you're just saying that the lunar regolith consists of broadside distribution of particles created by bombardment of micrometeorites, etc. And in particular, smaller particles are susceptible to the non-gravitational force. In this case, and this is the concept of the instruments, by applying different electrical field close to the surface, it is possible to allow dust particle deposition on dedicated sensors that are placed very close to the area of interest. In particular, the MOVIDA instrument, it is the goal and the concept. This is developed by an Italian consortium, and the main goal of the instrument are the measurement of the volatile content in the lunar dust and the characterization of the electrical properties. The instrument is mainly based on an array of piezoelectric crystal microbalances, whose the sensitive part is an electrode that acts as a collector for the micron and submicron particles. This is the scheme of the instrument. The instrument is based on two sensor heads. The first one is the charge PCM that function with a capacitor to in order to have a local electrical field to attract the particle, and the second one is a thermal PCM that is completely different sensor head, and is mainly used thermogravimetric cycle to characterize the volatiles in dust. The sensor has own proximity electronics, and while the main electronics unit can be shared with the main electronics of a rover or a spacecraft, depending to the scenario and to the payload. The technical characteristics of the instruments. So the main signals is a frequency around 2-3 kilohertz, and the total mass of the sensored 1 and 2 is below 500 grams. The instrument can functioning is in a different way, so in different mode, in passive, that is means accumulation of particles, and in active mode by using the capacitor, or by using thermal cycle with an integrated heater on the sensor. You have to think that only 0.5 watt are necessary to obtain a delta T of 250 Kelvin. In this case, the sensitivity is 5 nanograms, and the method used mainly are the contaminants and dust accumulations, TGA cycles, and the local electrical field to measuring the electrical property of dust. The heritage of MOVIDA. MOVIDA has been proposed to ESA RFI in 2009 and 2018 for drone exploration campaign science and technology. But the heritage is mainly based on 3 different ITT ESA project, technological project, CAMLab, and on the heritage coming from ESA HERA mission on board the CubeSat Milani, and for Zhangha mission, CNSI mission, where the sensor 2 is part of the dust package. These are some of experimental tests that we performed in thermal vacuum chamber, and as you can see, this instrument converts the mass change into fundamental frequency variation. And according to Sauer-Brei equation, when we have a deposition of particles or molecules on the sensors, we have an increase of the frequency, as you can see in the plot at right. These are some figures that were acquired from the SEM analysis. And here you can see some particles in the order of 1 micron and 2 and below. And as what is the behavior of these particles? So they tend to have to create some aggregates of particles, like fluffy particles and single particles, as you can see in this figure. The tests, this is some simulation of tests of deposition tests performed in thermal vacuum chamber, and we were at 10⁻⁷ millibar here in a temperature range of -20. Here we use the engineering model of these instruments, you can see here, and we heated a contaminant source that in this case was an organic compounds from 40 degrees up to 60 to have an increase of the frequency, so an increase of deposition mainly, as you can see here, the blue line. Then after the depositions, we used a different thermogrammetric cycle, that are this thermal cycle here, up to 100 Celsius degree, to characterize the organic compounds and to perform the desorption from the sensor surface. In this case, we can see that the main desorption of this compound happened in the temperature range from 20 up to 50 Celsius degree. So the conclusion, MOVIDA instrument is suitable for lunar in situ missions, and it's mainly low mass, volume, and power requirements. Is composed by 2 different sensor heads for 2 different aims, and it is under evaluation by the ESA for the lunar exploration campaign science, and it has a very strong heritage that are coming from VISTA HERA mission, the 3 technological project of ESA, ITT, and also the next mission of Chinese mission, Zhangha. Thank you. It's all from my side.
Okay, super. Thank you very much. Do we have some questions? Maybe I'll go ahead and get started. So you would foresee that you would put this instrument on multiple missions to different parts of the moon to then collect information from different locations?
Yeah, it is possible to put the instruments depending to the goals of the mission. For example, close to another sensitive instruments or close to an area of interest. You have to think that these sensor heads are can be proposed like only one, but it's also possible to divide them and to choose the ones that is the best for the scenario. If you want to, for example, characterize volatiles, the second one is better. So the first one is for the electrical property of dust. So it's very flexible.
Okay, yeah, I mean it's very attractive because it's small and doesn't have a lot of power requirements. So yeah, I mean, would this be also something that you could propose for a CLIPS payload or?
Yes, it could be.
For the NASA CLIPS.
Yeah, it could be. You have to think that this sensor that you can see here was developed for Hera. And is only 80 cubic centimeter here, that one. And this is very similar. It was for ESA always, but for another project. So yes, the answer is yes. We can propose it for a spacecraft or a rover, and it's very small, and the power required is around in passive mode 0.5 watt. In active mode is around 1 watt to 1.5.
Okay, super. John, did you have any questions? I see that we don't have any questions in the chat.
No, nothing immediately.
Okay. Yeah, so the CNSA Zhenghe mission, is that an asteroid mission? I've kind of lost track of all of what they're planning.
Yes, it's as you well know, maybe it's not very easy to have information from China, but yes, the aim was to the first one was to characterize the LST Pizarro, but now they changed the objective of the mission. So, but what they proposed. It was a call for instruments of other countries, and in particular, we were selected for the dust package that is in the mission mainly, and one of these sensors that you can see here was selected with another one that is going that developing is still ongoing. But mainly is a part, this kind of sensor is part of their dust package.
Okay, that's good to know. And so, and then in theory, it could also be proposed for one of the Chang'e missions that's coming up, if there's a payload call for any of those, or for their International Lunar Research Station. Yeah.
Yeah.
Okay, super. Thank you very much.
Thank you to you.